Hello everybody. Today is the first session dedicated to CIS 101 and I, Professor Knizhnik, Leonid Knizhnik, will conduct this session. First of all, I would like to congratulate you for your choice to take CIS 101, which is absolutely necessary in contemporary world because computers are everywhere in every application of human knowledge. So when you really computer literal, all roads are opened. What we're going to do in this course? The course will contain two big parts. First part is theoretical information about electricity, electric current, magnetism, magnetic field, codes, encoding, a little math in the basics of the computer, because computer is electrical and electronic device and functioning under influence of electrical field, electrical current, electromagnetism, and actually without knowledge of these matters we will be helpless. We never will understand how computer functioning. But it's very important not just to know how to push the buttons, but to feel, to understand the internal structure of the computer and to know how computer works. So folks, first of all, I would like to speak about the universe and matter. What is matter? Matter is material actually contained small fractions, small particles. These particles are containing smaller particles which named protons and electrons. What's the name of these particles? They named atoms. Atom. These atoms, folks, actually containing internal particles. The nucleus of this atom, and they usually contained positively charged fractions named proton. These protons, folks, sitting in the kernel, in the nucleus of the atoms. But the atom is electrically neutral, so the charge of the proton must be balanced with something charged with negative charge. And the negative charge is the cloud around the nucleus. And this cloud is negatively charged, and elements of this cloud, which actually create the charge of it, named electrons. One more neutral electrically element named neutron create the all material factors, all the hard body of everything, stones, metals, gases, liquids, whatever you can imagine. So the atom that I draw here is atom of hydrogen. Different atoms, actually, folks, with a different charge create a different elements. So this element named hydrogen. But another element which is containing more protons, like 8 protons and 8 electrons. I'll put them like a cloud. 1, 2, 3, 4, and 5, and 6, and 7, and 8. 8 electrons. This element is much more complicated, so it's oxygen. So folks, when we connect these two elements, 2 atoms of hydrogen and 1 atom of oxygen, you get H2O, which is the water. Water is the basis of everything that's alive. Now, what about metals? What about electricity that metal is conducting? First of all, I would like to tell you folks that when electrons moving inside of the atom, they have the energy. What is energy? It's very difficult to define. Energy is something that converts one situation to another situation. For example, if you have just empty teacup and you would like to have a tea, so what you need to do, you need to take a kettle, put it on a gas stove and transform the energy from the gas to the water in the kettle and then prepare the cup of tea. So this situation actually defines energy as something with a cause and reasons. So without energy that transformed itself to the water and boiled the water, there will not be a tea. So the energy, folks, also connected to such definition like entropy. Entropy, folks, is a measure of chaos, measure of disorder. So if I put everything like in disorder, like a stones like this, and you can see the stones just in a desert, this is maximum entropy. So there is no order. But if I take the stones and I put them in order and I can make the house, take a look. I'll put them here and I can make the house, folks. But to put them in the walls of the house, I need to spend my energy and get tired. Alright, so all elements, folks, in the microscopic world of atoms, they have energy. And to use this energy, to convert this energy, is very important to make our world to motion. We need to make it motion. But in this case, we need to transmit the energy. And what is actually give us opportunity to transmit this? Conductors and electricity. So how to transmit the energy of electrons? What actually can be instrument of this transmission? I'll tell you, folks, that metals actually conductors of this energy, and energy named electrical current. Let's review the internal structure of metals. Metals has nucleus connected to each other, nucleus with protons. And take a look, I will connect these two nucleus, and then I will connect another two nucleus of the metal with each other. So you will see the grill. So then we will connect two more nucleus to each other, and then connect other nucleus to each other. Okay? And then I'll go to connect more of this, because they are very small particles, nucleus of the metals, and they connected, and here is more of them. And then you will see, folks, what I drew here is a wire. So that is internal structure of any wires. And let me go further and further and further, and you'll see like this wire goes and goes and goes. But where's electrons, folks? Where are electrons? Where they are in this structure? In between of the nucleus. So as soon as metal is very hard and nucleus are connected to each other, electron, like clouds, can fly inside. You can see this picture in the lecture which is recorded. The picture is animation. So this is not a particle, this is rather clouds. But I made a snapshot of these electrons, and they're everywhere. So without any efforts from the side, all of the electrons actually just jumping around in between of the nucleus. But then you know that there is a chemical source of electricity. Chemical source of electricity is, let's say, it's battery. Battery actually has chemical reaction inside. Let's say AA, right? AA. Chemical reaction inside which actually separate positive and negative charges. So the positive pole is here, that is positive, and negative in the bottom. So what's happened if we go and connect our positive piece to the bottom of this wire, and the negative we will connect to this nucleus. Look what's happened. The positive charge will go to the metal and will create positive electric field in this bottom end. So electrons, because they are all negatively charged, they will run to the positive charge of the far end of this conductor. But this end of conductor will be charged with negative charge. Negative charge will not attract electrons, it pushes them away. So electrons will fly away from this particular end to the far away end of this conductor. And direct motion of these electrons created electric current. Folks, what's happened if the power source, not double A battery, but we'll say that is electric outlet, like this one, right? In the wall. Electric outlet. It could be the same thing. So, but electric outlet could have much more electrical juice. If battery has electrical measurement like 1.5 volt, so volt is actually the level of electricity inside of this, but outlet will have 120 volts, and this is standard for American electrical outlet. With more powerful electrical source, electrons will fly with a bigger speed, with a higher velocity, and eventually they will bump to the internal connection of the metallic grill, like this you can see. But when they bumped, they will create the energy of the bumping, so that electrical energy of the chemical reaction inside of the battery will be transformed with the temperature of this conductor. And eventually the temperature can go to be very high, like it happened in a light bulb. Take a look, folks. Light bulb is the glass that has electrical spiral. And we can connect the light bulb to the outlet with a switch, of course. When you push the switch, the electrical current will go through the internal metallic incandescent spiral, and spiral will be very hot, so we will see it as a light source. When you release the button, of course, the light bulb will be in darkness, so the electrical current will be cut off. So folks, what is the definition for electrical current? So electrical current is direct motion of charged particles. So definitely manifestation of electrical current is everywhere in use. So we can create a motion from electrical current, we can create heat from electrical current, we can create light from electrical current, and even magnetic field and radio wave for communication. So that is extremely important to know what is electrical current. Again, if you connect electrical source of electricity to the conductor, and this metal like copper or iron or silver, they are very good conductors, and they used to create conductors for the home usage for electricity and for industrial use. So this is extremely important to understand what is electrical current. So folks, we're speaking about manifestation of electrical current. And I mentioned that electrical current can give you a heat, electrical current can produce light, but I would like to speak about one more manifestation of electrical current. Electrical current create magnetic field. Folks, that was discovered in 18th century. So when you have a conductor, let me draw the conductor like this, could be copper or aluminum, and you connect this conductor to the battery, to the electrical source, let's say AA battery, and you will connect the other end too. So the electric current will go through this contour, will go from plus to minus, because we talking about electrons, which goes from minus to plus, but current direction of the current will be opposite. So that will be opposite to electrons, because electrons are negative. So the direction of the current will be from plus to minus. And if you put the magnetic putter made of iron, you will see putter will be allocated like rings around this conductor, like rings. Why they oriented like rings? Let me draw another experiment. So that is conductor, which is in a table, and it will be under the table too, like this. And we will connect battery to this conductor. When we connect it and put the magnetic putter around, the magnetic putter will create rings this way, magnetic rings like this. That actually make possible for the scientists of 18th century to define that electrical current also manifests itself with magnetic field. Magnetic field. What is magnetic field? What is manifestation of magnetic field? Folks, magnetic field has a feature to attract magnetic materials like iron, cobalt, and neodymium, and many others. You know the magnets, the permanent magnet that looks like this, right? So that magnet, okay, looks like a horseshoe, and one of them is green, another one is red. So magnetic field as an electrical field has two poles. They call it South Pole and North Pole. Why so? Because the planet Earth also has magnetic field, because the internal part of the planet is iron. So the North Pole has magnetic field at the north, and South Pole with Antarctic is a South Pole. So it's the same as a huge magnet. Thankful to this magnetic field of the Earth, which is actually go this way and this way, we will not die, because the radiation that came from the sun will be closed by magnetic field, will be eliminated, so we can survive. So folks, let's try to figure out how can we use magnetic field for communication. If we know that magnetic field created by electrical current works to attract magnetic materials, let me do a certain interesting things. One little conductor has very small magnetic field, but I would like to make it more powerful for magnetic field, so I will make a loop of the conductor, and then I will put the second loop of the conductor, and then the third loop of the conductor, and make, let's say, 100 loops of the conductor. So I will make a coil. If I take the bottom of this conductor and connect it through the switch, I would like to have a switch everywhere, to the battery. So when I close the contour and electrical current will go through this contour, through the coil will create magnetic field. Magnetic field will go this way. It's invisible, but you can feel it when you put here something that can be magnetized to this coil. So that could be a key, right? Because key made from the magnetic materials. So look what's happened. When you push the button here and create magnetic field, then key will jump from the table and will be magnetized by the coil. When you release this, then this key will fall down on the table again. Folks, this already the informational contour. Why so? Let's consider that we have conditions. So when the key jump up, that will be yes. And when it is not jump. That will be no. So you ask somebody, is it true that you already have diploma in Medgarev's College and you do not push this button and that key will not jump up to the coil? So that's meaning no. I will remanufacture this question. I will say, are you a student of Medgarev's College? And then you will push this button, the current will go through the coil, and the key will jump up, will snap up to the coil, because magnetic field will take it from the table and will force it to jump to the coil. So folks, this is a system that allows you to use logical answers, yes and no. I will say that yes usually is true, I can reform the question, and no is usually false.